Hi guys, today we are going to continue to look at determinants, but we are going to look at them for 3x3 matrices. And I know that the lesson title involves the word inverses. We're not going to look at inverses today. We'll save that for tomorrow, and tomorrow you'll see why. So, determinant of a 3x3 matrix. First of all, I want to tell you, please don't freak out because this looks super intimidating, but it's really not. And I'm going to show you what this is all saying. If we have a 3x3 matrix, A equals all this, then to find the determinant, we are going to start by looking at the main diagonal. So main diagonal being right here. And you can see here that I just multiply those three numbers together, and that's my first number. Then I'm going to look at this is in your textbook too, and I do have a typo. That should be a 1. I'm going to take the next diagonal, and I always need an A, a B, and a C. One number from each column, one number from each row. I'm going to multiply these three numbers together, and that becomes my next number. Then I have this A3, B1, C2, and that goes right there. So all I'm doing is taking diagonals that are going the same direction as my main diagonal, multiplying them together, and then adding those values together. Notice here that the sign in the middle is still a minus. When we did 2x2 matrices, we did the main diagonal minus the other diagonal. So then I'm going to look at the other side, and I have the first diagonal like this, and that one's this one over here, B3 or A3, B2, C1. I'm going to have this one here, and probably the hardest part is just for people to remember, like, am I putting this one with this part or this one with this part? There should only ever be three numbers that you multiply together. So that would be here, and then this one with these two. So, looks super intimidating. I'm not trying to freak you out. I'm not going to give you this formula for a test, but once you see it drawn out, and we're going to work through some examples, hopefully you'll see that this isn't the worst thing that we're going to do ever in the whole class. So, I'm going to start with my main diagonal. All it's asking me for is determinants. So I'm going to go like this, and I'm going to multiply these numbers together. -3 times -5 times 3. Next, I'm going to have 2 times 2. And then remember, I'm not using 4 and 1 because that would give me 4 numbers. I'm using the 0. So I'm going to have 2 times 2 times 0. And then finally, I'd have 0, 4, and 1 that I'm multiplying together. All right, so recall from the formula that I'm subtracting the big picture right here, but in between I'm doing adding. So I'm going to go back and put some add signs in there. And one way to make sure that you've gotten everything is that I should have 9, there are 9 numbers in the matrix. I should have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers before I start simplifying. All right, so let's change it up now and do the other direction. We'll use the light green. And I'm going to start on the diagonal that goes the opposite way. And that's going to give me 0 times -5 times 0. Then I'm going to have 2 times 4 times 3. And then finally, I have -3 times 2 times 1. All right, so pluses in the middle, and then remember, big old minus sign in between the two big sets of parentheses. So let's do some simplifying here. When I simplify this, I'm going to get positive 15 times 3 is 45, plus 0 plus 0, minus, over here I'm going to get 0 plus, this would give me 8 times 3 is 24, negative 3 times 2 is negative 6, times 1 is also negative 6. So I'm going to get 45 minus 18, and that's going to give me 23. Yeah, so this would be the determinant of my 3 by 3 matrix. And this is pretty much all we're doing today. So which diagonal do I start with? The one with 2, 0, 3 or the one with negative 1, 0, 1? I always start with my main diagonal, which is this one. So 2 times 0 times 3. And then I'm going to keep using color changes. Obviously, if you want to use them, you can, but if you're just using a pencil or one pen, that's fine too. I'm going to get 0 times negative 5 times negative 1. And then 1, 0, 0. 1 times 0 times 0. So putting all of that in parentheses and pluses in between, then a minus sign. I'm going to put my big parentheses there. I should have a plus and a plus. All right, now let's switch directions. I'm going to now go this way, and I get 1 times 0 times negative 1. We'll do that one. 0 times 0 times 3. And finally, I'll get 2 times 0 times negative 5. Now, when I look at these, I see that every single set of parentheses has a 0 in it, which means I'm going to get 0 plus 0 plus 0 minus 0 plus 0 plus 0. So really, my answer is just going to end up being 0. Now, from what we learned about 2 by 2 matrices, does this mean that our matrix does or does not have an inverse? It does not. It doesn't ask that question, but it's a good review. And like I said, we'll look at inverses of 3 by 3 matrices tomorrow. All right, so final step, or final example, we are going to determine whether the matrices are multiplicative inverses. What were some of the key characteristics of multiplicative inverses? What has to be true for two matrices to be multiplicative inverses? So some things that have to be true is that they have to have the same dimensions, and they have to be square matrices. They also have to, when we multiply them together, we get the identity matrix, which is the one that looks like this. So when we multiply these together, if we do not get this, then we would say they are not multiplicative inverses. But if we do get that, then they are. So I'm going to start with the order that they're written in. So I'm going to look at row and column. And I'm going to get 0 times 1, which is 0, plus 0 times 0, plus 1 times 1. So that just gives me 1. So far, so good. Then I'm going to look at the first row, second column. And I get 0, because 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. So I get another 0. And then finally, when I multiply these together, I'm just going to get 0. Now, moving on to the second row, I'm going to have this row times this column, and I get 0, 0, and 0. When I look at it with the second column, I get 0, 1, 0. And then with the last one, I get 0, 0, 0. Finally, when I multiply these together, I get 1 plus 0 and then minus 1. And so that would give me 0. Looking at this one, I'd get 0, 0, 0. And looking at the last one, I would get 1, 0, 0. Oops, I didn't put that. Yeah, I put that 0 in there. And then 1. So far, so good. This is the identity matrix. But now remember, I have to flip it around and I have to multiply them the other direction. So I'm going to have just going to rewrite this. So we get, and we can't just assume that because it works for one of them that it's going to work for all of them. So we do need to go ahead and multiply these together. When we multiply these together, try it on your own first and see, do you get the inverse or the identity matrix? So when you do your multiplication, you should end up with another identity matrix. So since both of these, when we multiplied them, even when we switched the order, since they both gave us the identity matrix, that means that these matrices are multiplicative inverses. If you have any questions, please let me know. Like I said, tomorrow we'll take a look at how to do 3 by 3 matrix inverses, and we'll take a look at that tomorrow. So make sure that you bring any questions for this lesson to class or send me an email. Let me know what you have questions on. Thanks, guys.